History is a vast, shadowed library with countless volumes lost to time. We marvel at pyramids and colosseums, but what have we forgotten? Among the ruins of powerful empires, archaeologists sometimes find objects that simply don't belong. They challenge our understanding of the past. These are called out-of-place artifacts, items so advanced they seem to defy the technological limits of their era. They whisper of lost sciences, of knowledge that flickered brightly before being extinguished, leaving us with only questions. Could our ancestors have harnessed forces we believe are modern inventions? Could they have understood principles of chemistry and physics we thought were centuries away? Imagine a world where the spark of innovation took a different path, a forgotten branch of technology's family tree. Today, we explore one of the most compelling and controversial of these artifacts, a simple clay pot with an electrifying secret. It was discovered near modern Baghdad, in the heart of ancient Mesopotamia, a cradle of civilization. This humble object, no bigger than a man's hand, could rewrite our timeline of technological achievement. This is the story of the Baghdad Battery, and the question it forces us to ask: did our ancestors have electricity? The year is 1936. Amidst railway construction near Baghdad, workers unearth an ancient Parthian settlement, frozen in time. Among the pottery shards and historical debris, a collection of peculiar clay jars is found, initially dismissed as simple storage vessels. These artifacts were taken to the National Museum of Iraq, where they sat catalogued but largely unexamined for years. Then, in 1938, Wilhelm König, the German director of the museum, took a closer look at one of these unusual jars. He noticed something strange. It wasn't empty. Inside was a construction unlike any other pottery he had ever seen. The jar was about 5 inches tall, made of simple fired clay, an ordinary object on the outside. But sealed into the top with bitumen, a type of asphalt, was a cylinder made of a rolled sheet of copper, and suspended inside that copper cylinder, held in place by another bitumen plug, was an iron rod. The iron rod showed signs of being corroded by an acidic substance, a clue that something more than just air once filled the jar. König recognized the arrangement: 2 different metals, separated but ready to be connected by a liquid. He had a shocking hypothesis. Let's deconstruct this ancient puzzle. The outermost layer is a simple terracotta vase, a common vessel from the Parthian period. Its presence helps date the artifact to sometime between 250 BC and 250 AD, a time of great cultural exchange. Next, the copper cylinder, meticulously rolled and placed within the jar, not touching the sides. This separation is crucial. Copper was well known to ancient metalworkers, used for tools, jewelry, and currency. Its presence here isn't unusual, but its form is. At the very center, we find the iron rod. Iron was a more functional metal, less precious than copper. Like the copper cylinder, this rod is also isolated, suspended so that it doesn't touch the copper at any point. Holding it all together are plugs made of bitumen, a naturally occurring asphalt. It acts as a sealant and an insulator. The bitumen cap holds the iron rod in the center of the copper cylinder, creating a precise and deliberate arrangement. So we have 2 different metals, an iron cathode and a copper anode, insulated from each other and housed in a pot. The only missing piece is a liquid, an electrolyte. When you add that, this humble pot transforms into something remarkable. Wilhelm König saw this arrangement and was reminded of something from his modern world, a galvanic cell, or simple battery. The principle was discovered by Luigi Galvani and perfected by Alessandro Volta in the late 18th century, or so we thought. König's hypothesis was radical, that Parthian artisans, 2,000 years before Volta, had independently discovered the same principle. He published his theory in 1940, suggesting this was not a vase, but a source of electric power. The idea was astonishing. It suggested a level of scientific understanding in the ancient world that was completely unexpected. If it was a battery, it would produce a low but steady electrical current. But how? The key is the electrolyte, a liquid that can conduct electricity. The ancient world had several readily available options. Simple grape juice, or more acidic vinegar or wine, would be enough to kickstart the chemical reaction needed. The acid in the liquid would dissolve the iron rod, releasing electrons. This is the fundamental process of a battery. These electrons would then flow from the iron to the copper, creating a voltage, a small but usable electrical potential. So, how exactly does a splash of grape juice turn this pot into a power source? It's all about simple chemistry. The 2 metals, iron and copper, have a different electrical potential. The iron wants to give up its electrons more than the copper does. The acidic electrolyte acts as a catalyst and a medium, allowing these electrons to begin their journey. The acid in the juice starts to eat away at the iron rod, a process called oxidation. This frees electrons from the iron atoms. These freed electrons accumulate on the iron rod, creating a negative charge. Meanwhile, the copper cylinder develops a relative positive charge. This difference in charge between the two metals creates a voltage, a pressure for the electrons to move. If you connect the two terminals, the iron rod and the copper cylinder, with a wire, the electrons will flow. This flow of electrons is what we call an electric current. It's a tiny, controlled stream of power. Modern replicas using this exact setup have successfully generated between 0.5 and 1.5 volts of electricity. It's not much by today's standards, but for the ancient world, even this small amount of power could have been revolutionary. So, if the Parthians had a battery, what did they do with it? The leading theory is a process called electroplating. Electroplating uses an electric current to coat one metal object with a thin layer of another, often a more precious metal. Imagine wanting to make a copper bracelet look like it's solid gold. Electroplating is the most efficient way to do it. To do this, you would need several batteries linked together to provide enough voltage. The process is slow but effective. The object to be plated, like a small statue, would be connected to the negative terminal of the batteries. A piece of pure gold or silver would be connected to the positive terminal. Both would be submerged in a special salt solution. The electric current would strip tiny particles of gold from the nugget and deposit them evenly onto the statue. After several hours, the bronze statue would emerge with a perfect, thin coating of pure gold, a masterful illusion. This would explain some artifacts from the period that appear to be gold-plated, though the technique was thought to be much more recent. It was a way to create luxury goods, a secret craft that could have given one group of artisans a huge economic advantage. But electroplating isn't the only theory. The small voltage produced could have been used in other, more subtle ways. Some researchers have proposed a medical application similar to modern electroacupuncture or TENS machines. The mild tingling sensation produced by the current could have been interpreted as a form of healing energy or pain relief. Imagine a healer applying this divine energy to soothe ailments. It would have seemed like powerful magic to the uninitiated. Another compelling idea points to a religious or ceremonial purpose designed to inspire awe and reverence. A priest could hide several batteries inside a metal statue of a god or an important relic. When a worshiper touched the statue, they would complete the circuit and receive a small, surprising electric shock. This tingling sensation, this touch of the divine, would be undeniable proof of the statue's power and the priest's connection. This would be a powerful tool for social control and reinforcing belief, using hidden science to create perceived miracles. Whether for healing the body or captivating the soul, these theories suggest a purpose far beyond simple decoration. However, for every exciting theory, there is a skeptical counterpoint, and the Baghdad Battery has many. The most common mainstream archaeological view is far more mundane. These were simply storage vessels for sacred scrolls. In this scenario, the copper cylinder would protect the delicate papyrus from damage, and the iron rod was simply a spindle to wrap it around. The acidic residue found on the iron rod, skeptics argue it could be from the decay of the papyrus scroll over centuries. Similar objects used for scroll storage have been found elsewhere in the ancient world, lending credibility to this theory. Furthermore, the bitumen seal at the top completely covers the copper and iron, making it difficult to attach wires. Bitumen is an excellent electrical insulator. Why would you seal a battery with a material that prevents you from using it? Perhaps the most damning piece of evidence against the battery theory is what hasn't been found: any wires. For electroplating or any other electrical use, you'd need conductive wires. Not a single one has been found with these artifacts. Without wires and with a sealed top, the battery hypothesis, while fascinating, remains difficult to prove conclusively. The debate rages on, but some have moved from theory to practice. Can a replica actually work? Numerous researchers, scientists, and television shows have constructed their own versions of the Baghdad Battery. Using materials that would have been available in ancient Mesopotamia, they put the theory to the ultimate test. In 1978, a German Egyptologist, Dr. Arne Eggebrecht, connected several replica batteries and reportedly plated a small silver statue. Students at Smith College in the United States also built a replica using grape juice as the electrolyte. Their single jar successfully generated about half a volt of electricity, proving the basic concept is sound. The show Mythbusters also tackled the mystery, linking 10 handmade jars in series to increase the voltage. They generated enough power to produce a noticeable tingling sensation and even to do some minor electroplating. These experiments don't prove what the artifact was used for, but they undeniably prove what it could have been used for. The science works, the materials are correct, the possibility is real, even if the proof of intent remains elusive. So, did ancient people have electricity? The answer, frustratingly, is maybe. The Baghdad Battery proves it was possible. It stands as a powerful symbol of lost knowledge, a technology that could have been, but perhaps never was fully realized. Was it a battery, a source of power for gilding, healing, or creating miracles? The evidence is tantalizingly incomplete. Or was it simply a high-tech scroll case, an elegant solution for preserving sacred texts? This is the more cautious, scholarly view. The lack of associated artifacts like wires remains the biggest hurdle for the battery theory. The dog that didn't bark. Perhaps the truth lies somewhere in between, a ritual object whose function we can no longer comprehend. Maybe its electrical properties were an accidental discovery, a curious side effect of its primary, now-forgotten purpose. Ultimately, the Baghdad Battery teaches us a vital lesson: never underestimate the ingenuity and curiosity of our ancestors. It reminds us that the path of technological progress isn't always a straight line. Sometimes there are detours, dead ends, and brilliant sparks that fade. The Baghdad Battery remains a silent clay and copper enigma, daring us to keep asking questions about our own past.